or in San Fran, or in London, but you have to face global.
The beauty of it is whether you're targeting the unbanked, of which there's a huge swathe across the world, or targeting the underbanked, or those with existing bank accounts or whatever it might be, you're talking about a population size that is vast. It's not like a small little startup that's focused on one tiny little vertical. I think the opportunity is huge. So that's quite exciting in itself.
A very, very difficult industry.
I think certainly some people tend to underestimate the amount of hard work it can be. It can be very stressful, it can be quite scary.
There's a lot of humps and bumps and difficulties.
Good morning, everyone. Good morning, good morning. Please come closer, have a seat here. Please go on the side. We're starting now. Guys, please come over. So thank you very much for coming. And it's a great morning today, Monday, start of the week, with a very, very exciting topic. My name is Anthony. I'm the co-founder of FINNOVASIA. I will talk a little bit about what is FINNOVASIA. We're very excited today because we have a very interesting guest. I guess many of you came here for him. It's me. No, okay. No, it's Vitalik. So Vitalik today is his second day in Malaysia in his life. And So let me give you a little bit of introduction about who we are and why we're here. So FINNOVASIA is coming from its name. We have a focus on three things: it's finance, innovation, and Asia. That's coming our name FINNOVASIA, right? We are based in Hong Kong, and we operate in different markets within Asia. And our focus is to bring together Fintech community, startups, founders, investors, governments, and regulators. And we do many exciting things, such as we are running the largest event in Hong Kong called FINNOVASIA. It's a Fintech conference. Last time we had over 500 people coming from 23 countries. Probably some of you been visiting there. I know some people have been there. We also do educational events around the Fintech area. And today we're here in Malaysia. Then I need to say special thanks to our major partner who made this happen, is MDEC. And give applause, please. And I must say we are very, very much impressed with the passion from the local government towards the Fintech. And it's very, very exciting. I understand that's sort of a little bit early stage for Malaysia in terms of development of this industry comparatively, but we see a lot of passion and energy coming from the government, which is a really, really good sign. And the fact that we have today Vitalik here is all thanks to this passion and of individuals within the government. I also need to say a few words of thanks to our partners who also supported us for this event, which is the Make Space, this amazing venue, Bitcoin Malaysia, and Fintech Street. Thank you very much. Also, before we start, I want to introduce one person with help of whom we made this happen. from MDEC. Ms. Dato Wan Peng, please go.
Thank you, Anton. Good morning, ladies and gentlemen. Very happy to see that we have full house, and I'm sure that you are here to listen to our distinguished speakers to share with us on blockchain. But before I go into that, some of you may be wondering why is MDEC now into the financial space? But don't forget fintech means finance and tech. And anything to do with digital tech is what MDEC has an interest in. So that is why we are here. And very proud to be partnering FINNOVASIA to host this event today. And you can assure that coming months, there'll be a lot more announcement, which I cannot do it today because since I say it's in the future. But I would like to give you a little bit of background of what MDEC is doing in the fintech space. We started looking at this about a year ago and wanting to know whether we should, as a country, we should even be putting an effort. Because a lot of people will be telling you that Hong Kong is doing so well, New York, London, Singapore, we have no chance. So don't even think about that. But we look at it again and again, we realize that is not the case. Malaysia have our unique proposition where fintech is concerned. As a country, we are a mid-sized country, population, diversity, we are very strong in financial, especially Islamic finance. And as a country, the composition of our people, as a developing country, we have a bit of underbank, very bank people. That means it's a very good place for test bedding any new idea, as well as a launching pad for anything that we want to do in the fintech space. And don't forget Malaysia, if you look at how people have been handling the payment, we see that there are a lot of areas that we can do something about. Not to forget Forex, remittance. So that means a lot of opportunities that we can develop Malaysia as a hub for a specific area. So we have identified Islamic finance as well as fintech in a developing country will be two of the key focus. Doesn't mean that we won't be looking at other things, but this will be the two focus area. So that is what we are doing. And in order to ensure that we can develop fintech in the country, there are many things we have to do. Do we have the right people? Talent development becomes key. Do we have the right policy, regulations to support it? On this note, I'm very happy to share that Central Bank, Bank Negara, Security Commission are very much with us and very aligned in the thinking. Early this year, governance of Central Bank announced the focus on fintech. That was, I think, his first formal announcement, and we are very happy. Meaning, we get the support from the key regulator, and then after that we approach and talk to SC. In fact, actually, before we even approach SC has already been working very, I would say secretly, but they have been doing a lot in the so-called fintech space. It's just that you don't call it that way. So on that note, we think that MDEC, from a tech perspective, the two regulators are actually with us. So we have the first, I think, critical success factors sorted out. Then after that, what we need to do? In the Q1, you are going to hear a lot of announcement in terms of what we are doing in terms of accelerator, what we are doing in terms of supporting startups, what are we doing in terms of supporting scale-ups. We believe that with all these important components coming into one place, we are able to move this forward very quickly. The way how we intend to do, just like the discussion with our partners, the regulators, we will do a different approach. We are not going to make a lot of announcement, but we are going to make sure that we enable the industry to move forward. We will let the result shows instead of making a lot of announcement first and wait for things to happen later. There's no right and wrong answer. This is just approach we choose to take. And we hope that we have all your support coming together to drive this. This is a space that's very interesting, has a lot of promise, and if we work together from local as well as regional and international players, I'm sure that you'll find Malaysia is a very good ground to launch and test bed any new ideas in the fintech space. With this, I present to you our speakers.
Thank you very much, Dato. All right, and I'm so excited to introduce you our next speaker. Probably he doesn't really need much introduction. Everyone knows about him, but maybe a couple of interesting things about his personality. I made some research and we had a conversation. So Vitalik was born in Russia, in a relatively small town next to the Moscow, in a family of computer scientists. And at age of 6, he moved to Canada with his family, where he finished the school, went to university, and dropped out after 8 months, and never come back, because he was fully focused on developing this platform, which became one of the most popular blockchain platforms in the world. Before the start, I want everyone to take your mobile phone, please. Take out your mobile phones. Not for the selfies. I know it's very popular here. I want you to go to the website called sli.do. Sli.do, sli.do.com. This system we will use for sending the questions to our speaker. Okay? You don't need to download anything, no need to install anything. Just go to sli.do.com and put FINNOVASIA as a password. FINNOVASIA, FINNOVASIA. Is everyone there? All right. Okay. So that's we will have a little bit of training. So there's a little bit quiz for you to choose. All right. So what was the Vitalik's favorite toy when he was 4? Rubik, Microsoft Excel, Lego, Tetris. Your choice, please. Okay. Rubik is leading. All right. Tetris. Tetris was invented by Russian too, mathematician, by the way. Okay. 44. Let's wait. Everyone, I want everyone to get used to the system, because we will use that whole day today for sending questions, liking other questions. Okay. Rubik is. I know you watched the movie Snowden, right? But it's different person. Okay. All right, everyone voted? Give more votes, please. 66, 72. All right. So, Rubik's Cube. And number 1, Tetris number 2, Microsoft number 3, Lego number 4. And the answer is, please, next photo. This is Vitalik when it's his 4. Can you see what is there? Microsoft Excel, he was favorite toy, according to his father.
Sorry? I think that was Word.
Anyway, welcome Vitalik Buterin on the stage, please. Give him applause.
I wanted to start off 1, 2, 3, 4. So I wanted to start off by going back all the way to the 1970s, before people even started talking about blockchains, before people started talking about decentralization, before people started talking about cryptographic money and even the internet. And back during the 1970s, this was a time when people were starting to write software for the first time. This was the time when computers were just starting to go from being something that existed in mainframes in 5 universities to something that existed in mainframes in 50 universities. And they suddenly became slowly but surely became more and more accessible. And this was the time when it just started to become possible for regular students in universities to actually write code for them. At first, code is something that, at the time, people would just write for fun. And people would write because it was an academic pursuit. They found it interesting.
I'm sorry,
and
Vitalik. Is everyone hear him well? Well? No?
Okay. Maybe switch the mic to something. Wah.
Yes, better.
So, at first, people were writing code because they thought it was fun, because they thought that it was academically interesting, because they wanted to help each other. But then as time progressed, big corporations started getting into writing code themselves. And this was the time when people started to realize that you could potentially write code, and you could potentially write code as a product, where you write the code and you sell it, and you close it down and you make people pay $50 or $100 for every copy. And there were a lot of people that were very unhappy about this. There were a lot of people who thought, wait, computer code is something that should be open. It's something that should be free. It's something that should be written collaboratively for the benefit of everyone and made accessible to everyone. And this is how the free software and this is how the free software and open source movement started. Right? It started with a group of computer scientists in universities that weren't happy with the way that computer software development was going, and they thought that they could sort of remake the world of computer software in a way that's more accessible, in a way that anyone can participate in as a developer, anyone can freely download software. If there is software, anyone can freely modify it, and if they came up with a way of doing things better, then people could freely share. And this vision and the vision of software being something that's locked down and made by corporations are these kind of two competing visions that ended up both taking their own paths all the way from the 1980s. Now, the surprising thing, though, is that as hard as it might be to believe, the open source approach, after 20 or 30 years of kind of constant ongoing competition and battle, is one that actually has, I would say, to a substantial extent, won. Right? So if you look at the software that's running the internet right now, if you look at the web browsers that we use, things like Google Chrome, Firefox, if you're Android, if we look at all of the kind of bottom-level software that runs our phones, our computers, the internet of today, very large portions of it actually are open source software that's free and open for anyone to download, for anyone to use, for people to share. And I would say that we really should be thankful for this. We really should be thankful for the fact that because of the efforts of all these people in the 1980s and the 1990s and in the 2000s, the internet is based on this infrastructure that is extremely accessible, not just for users, but also for developers to start tinkering in at the top level, at the middle level, even at the bottom levels, and where anyone is free to develop their own thing, to compete, and to improve. Like, if it weren't for that, I don't think we would even have one internet. I think we'd end up having like 5 or 6 internets that are all run by different companies, and I think the internet would be or what would be the networks that we would be using would just be much lower quality and have much less interesting stuff on them than the internet does today. But there's a problem. So even though I think the internet and open source software and its success is a testament to both the value of openness in technology and to the practicality and the fact that it actually is possible to create an entire self-sustaining economy and society that's heavily based on it, even still, just the fact that the code is freely available does not do everything. In the 1980s and the 1990s, most software had to do with things that individuals would privately do on their own computers. If you look at word processors, things like Microsoft Word, they're just things that people would download on their own computers. On their own computers, people would write documents, people would save documents, and people would share documents with each other. Now, one thing that's important, of course, is that if I write a document and I send the document to you, you should be able to open the document. So this is the value of open standards. So this is another thing that people really cared about for the last 30 years and has really proven to be very successful and important. Files, documents, things that people create using one software package can be opened using another software package. You're not locked in. That's something that's proven to be, I think, extremely valuable and extremely helpful, both in making the internet more efficient and in making it a place that's free and open to competition, instead of just having one company that's dominating it. So that's what the battles that were fought in the 1980s and in the 1990s. The problem is, over the last 10 or 15 years, the kinds of software that people are most interested in has changed. These days, it's not just about what the things that people do on their private computers. It's not just about the things that people do by themselves. In the 1990s and in the 2000s, we've had the internet. And the kinds of things that people are interested in doing these days are overwhelmingly activities that involve communicating between users at every step of the operation. If you buy something from an e-commerce website, that is an application that runs over the internet. If you send money to someone, that is another application that runs over the internet. If you post a message on some public forum, that's another application. It runs over the internet. That has to, where every single operation is one that necessarily involves communicating between one person sending information and either one person or many thousands of people receiving it. If you look at internet forums, one important piece of an internet forum is an identity. How do you even know that the person who posted one message is the same person who posted another message? And is the same person that might have some kind of identity in real life. That's the identity problem on the internet. That's also very important. And that's also itself, I would say, an application that involves communicating from one user to another. So in this kind of world where you're dealing with data that gets passed from one user to another almost every second, and where gigabytes, terabytes, or petabytes of data that users send gets stored, it has to be downloaded later. The concept of openness, I think, needs to take a bit of a broader definition. Just the fact that the software that people run on their own computers is open by itself isn't enough, right? I think that if we still want to get the same kinds of benefits that openness provides, both in terms of innovation, in terms of competitiveness, in terms of accessibility, then it's clear that we don't just need to open code where the code is something that anyone can freely run and download. What we also need is what some people have started to call open execution. So it's not just about the code, it's also about the code running in such a way where the process of executing the code is actually something that's not kind of closed down and running on some particular server. It's something where it's about writing applications where the data and even processing the data is done in such a way where people can more freely participate. And I would say that this kind of spirit is where blockchains start to come in. So how would you explain blockchains? So first of all, I mean, the first blockchain that originally right. Wow. 1, 2, 3, 4, 5. So the first blockchain that came about was Bitcoin, created by Satoshi Nakamoto in 2009. And the problem that Satoshi was trying to solve is essentially creating a form of decentralized peer-to-peer electronic cash. So Satoshi thought, okay, there already are quite a few online payment platforms, but the way that these payment platforms are designed is they're centralized, they're controlled by one company, they're closed. It's a closed ecosystem where if you want to be part of that ecosystem, you have to join this service that's created by one particular company, and where that one particular company is the gatekeeper. It's one where you have these centralized intermediaries that are charging high fees and quite often restricting users that aren't from a particular country. And he thought, well, what if we could create a form of money where that money itself runs on the same principles as the open internet? It's an open network where anyone can participate. There is no single centralized gatekeeper that controls access, that decides the truth, where you have to go through that one company in order to participate in the system no matter what. And the question is, can you create a system that has those nice properties, but in the area of money? Now, money is in some ways very different from many kinds of applications that people were trying to build before. So, for example, what kinds of things were people trying to do on the internet in the 1990s and in the 2000s? Most of the time, it was just passing messages. Now, passing messages is actually pretty easy. If I send a message, and I want you to receive the message, there's only two people in the world that need to know that message ever took place: the sender and the recipient. So decentralization, in sending messages, is actually quite easy, right? All you need is to have a way for the sender to send a message to the recipient directly. And if you can do that, if you can make that work well, then you're basically done. Money isn't like that, and here's why. So let's say I have $50, and I send those $50 to Anton. Now, let's say I then send another message where I send the exact same $50 to some other third party. You know, that's something that I should not be allowed to do, right? If I have $50, I should not be allowed to send $50 to one person and $50 to another person, because then I'm turning $50 into $100, and we can't have that, because if we have that, then the currency hyperinflates faster than Zimbabwe. So the question is, though, how do you solve the problem? And the thing is that money isn't just a message. Money isn't just something that I send to you. Money is fundamentally social consensus, right? And in order for the system to work, like, there has to be some way where when I send those $50 to a third party, there has to be some way that the third party can find out that I already send those $50 to someone else, and so I don't have those $50 anymore. Money is something that requires some notion of consensus, what I would also call some notion of state in order to work, right? So what do I mean by state? Basically, some kind of information that people in the network all have to keep track of, and at least in some way. So in the case of money, the state basically is, well, who has how much money? If I have $30, then I should be able to send $30 to Anton, but I should not be able to send $60 to Anton. If someone else sends me $30, well, now I should be able to send $60 to Anton, right? So this is a property that many other applications don't have, right? In a lot of applications, all you need is just be able to send messages from one person to another person. But now all of a sudden, whether or not one message from A to B took place has a lot of impact on whether or not a message from A to C can take place, or whether a message from B to C can take place. This is something that's fundamentally different and fundamentally harder. And now, one way that you can resolve the problem is you can just rely on a centralized server, right? You can have one particular kind of bank, agency, company, government, whatever, maintain one big computer, and that one big computer stores how much money everyone has. Now, this is one way of solving the problem. But the challenge is though that if you take that approach, first of all, do people trust that one central party? Second of all, is there a risk that one central party is going to start charging very high prices because it has a monopoly? Is there some risk that third party is going to start discriminating against some kinds of users for other reasons? So, if we want to build a system that's decentralized, then that's not a solution. But then you have the next challenge, which is if you want to build an application where that application is stateful, so it has some notion of state where the validity of messages depends on that state, but where that application is also decentralized, then solving that problem is what blockchains are all about, right? So Bitcoin was the first blockchain, and it solved that problem for one particular use case, which is money. It solved the problem of keeping track of the state, where the state consists of how many Bitcoins does everyone have. If you have 100 Bitcoins, then you can send 80 Bitcoins, but you can't send 120 Bitcoins. So it solved that problem. Now Bitcoin has since then, of course, done very well. There have been people using it for various kinds of applications and payments. There's people who hold it as an investment asset. Its market cap is over $10 billion at this point. But about 3 years after Bitcoin's launch, people started getting interested and thinking, maybe there's other applications beyond just currency that blockchains might make sense for. Currency is not the only stateful application that people are interested in, right? And so that's when people started looking for basically alternative blockchains. People started thinking, can you use the same technology that Satoshi used to solve this problem with Bitcoin? Can you use that same technology to solve the same problem in other areas as well? And so that's where Namecoin came from. So Namecoin is the second major blockchain that came out. And the purpose of Namecoin is to solve the exact same problem, but for registering domain names. So if right now he wants to register a website. So if, for example, he wants to register something like FINNOVASIAconference.com, then you actually have the exact same double spending problem, because what if I register a website, but then you discover that I registered this website, and let's say you're not a very nice person and you want to annoy me, and so you register the exact same website. Now, then the question is, okay, I registered this website, you registered the exact same website, who actually controls it? Now, the answer should be the person who controls it is the one who registered the domain first, right? So, but the problem is that that's a stateful calculation, right? If you want to remember who did something first, then you also need to have some notion of state. And Namecoin uses a blockchain in order to solve that problem. So, the Namecoin blockchain is like the second major blockchain that came out, and it has its own cryptocurrency, Namecoins that you can buy. You can use Namecoins to register domain names. There's people that are developing software for it, and this was an interesting kind of application that people built and that people started to try using. Now, after that, though, there were other applications that people got interested in. Some people got interested in using blockchains to register other kinds of digital assets. Some people were interested in using it to keep track of identities. Some people were interested in using it to keep track of financial contracts. Some people were interested in using it to keep track of insurance agreements, to keep supply chain tracking. So around 2012, around 2013, the number of use cases that people were thinking about really started to multiply. And at first, the way that people solved the problem is, every time they found some new use case, they would make a blockchain for it. Now, this worked fine for the first application, it worked fine for the second application, but the problem is if you keep doing it, you're just going to have such a huge number of blockchains that there's no way that all of them can be secure. So that's when people switched over to the second approach. And the second approach basically is, well, let's have a blockchain that supports many kinds of applications. Let's have some developers, where those developers all come together, sit down in a room, and they start thinking, what kinds of blockchain applications have people thought of for now? Okay, people have thought of finance, people have thought of domain names, people have thought of identity, people have thought of financial contracts. Let's make a blockchain where that blockchain supports four types of transactions. One type of transaction can transfer money. The second type of transaction can register a domain name. The third type of transaction can register an identity. And the fourth type of transaction can participate in a financial contract. And that's it. So this is how people were thinking in 2013. But then there were even more applications. And people started to realize, well, okay, if there's so many applications that people are creating, there is just no way that you can create a blockchain that can satisfy all of these use cases. And this is where I came up with the idea for So the idea behind Ethereum is this. Instead of creating a blockchain that is transferring money, or that's registering domain names, or designed just for registering identities, let's design a general purpose blockchain. So look at computers, for example. If you look at your computer doesn't have hardware chips that are specifically designed for running an internet browser or running running an operating system, running a word processor. Your computer has general purpose hardware that can understand a programming language. And on top of that general purpose computer, you can write whatever application you want, whatever kind of sets of rules or business logic that you want as code. And anyone can write this code, and writing the code is fairly easy. And once people write the code, anyone can download the code, and anyone can freely run the code on their own computer. And this makes innovation much faster and easier, because instead of every time someone creates a new kind of application, you having to sell a computer chip for it and get everyone to install the computer chip, you could just create a piece of code, upload the code to the internet, and if anyone wants to download it, they can just download the application from the internet and they can start running it. So the idea with Ethereum was to take the same kind of ease of use and bring it to the world of blockchains, right? So that's how Ethereum came to exist. Now, since then, I mean, when the number of applications that people have been interested in doing on blockchains has only increased, right? So at first, people were only thinking about those few applications: financial contracts, money, identity management, domain names. Then the applications started to increase even more. What if we could use the blockchains to run decentralized file storage systems? What if we could use blockchains for various different kinds of financial agreements, insurance agreements, microfinance, loans? What if we could use blockchains to store different kinds of digital assets? What if we could create financial contracts on blockchains where those financial contracts themselves use digital assets that are also on the same chain? What if you could build entire applications where those applications talk to identity systems, where they use digital currencies, where they involve financial agreements all at the same time? And as Ethereum and like other platforms continue to move forward, the number of things that people were interested in building on top of them just continued to increase. Right? So in 2014, there were maybe 20 or 30 applications. When Ethereum launched, there were over 100. Now there's over 300 applications that people are building on top of Ethereum. So the number of things that people are interested in doing is only continuing to increase, right? So now, of course, I would say in 2014, people were mostly thinking about what they can do. Now, Ethereum exists. I mean, lots of other platforms exist, and I think the discussion has moved on a bit. People aren't just thinking about what people can do with what people can do with blockchains. They're thinking about how they can actually start implementing it, and like what exactly is the path to go from an idea to execution to actually having millions of customers. And that's something that in many cases can be quite tricky, right? Because the thing is, it's very easy to come up with an idea, but it's quite a bit harder to come up with an idea and come up with a very clear story of why this idea benefits people right now, and to come up with a path for going from that idea to an actual product that everyone uses. And I think at this point, there are lots of ideas, and there are plenty of companies that are actually starting to build things based off of them. But we're at this next critical stage where we're moving from simple proof of concepts and very small scale startups to projects that are actually trying to take blockchain-based systems and push them out into the mainstream.
Vitalik, I'm sorry, I apologize for that. We probably will need to have time for the fireside chat, so we can continue conversation. And I also will encourage people to send the questions to Vitalik. But so far we have the most popular one. Can you speak closer to the microphone?
Oh, God.
Sorry for that. And I would like to introduce our fireside moderator today, who will have a continuing conversation with Vitalik. Is a Johnny Mayo, entrepreneur residence at Cairn Ventures. He's one of the 30 under 30 in the Forbes list. He's a blockchain enthusiast here, Malaysian-based, and he was the only one of the few people in Malaysia who were accepted as entrepreneurs in the 500 Startups Accelerator in Silicon Valley. Please welcome Johnny Maya as the moderator. Guys, have a seat.
try. Wah.
We
Why?
can do it. Mic check 1, 2. Okay, good.
Cool.
Okay, so first of all, I'd just like to say a big thank you to Anton, Alex, and the team at FINNOVASIA. Some of you may already know me. I've been involved in the scene here for a number of years. I helped found a company with a colleague of mine here today, Mark Smalley, called Neuroware. It's honestly extremely exciting to be able to see blockchain conversations here in Malaysia reach this extent. It's very exciting to see a technology whose time has come. And 2 years ago, we couldn't really have imagined not only meetups like this, but having such distinguished guests like this. So again, I'd like to say a big thank you to the people at FINNOVASIA and also the people at MDEC for putting the event on today. So Vitalik, there's quite a number of questions I'm sure you're all eager to hear. We don't have a great deal of time in order to pick his brains. But before we begin, one of the interesting points that you made there is you talked about the internet of 20 years ago. And one of the analogies I've always made is that 20 years ago, we really couldn't have predicted the internet that we'd have today. You'd never have imagined smartphones, you'd never have imagined applications, and the way in which it sort of encroaches on every area of our life. Do you think it's the same analogy for blockchain technology, and that where we are today, we still don't really know where this is going and just how big this could end up?
I definitely think that it's very early right now. I think we're at the stage where people have lots of ideas of what they want to do on top of blockchains. And there was a time in the growth of the internet where people were starting to think of what they can do. People were starting to think about internet forums. They were starting to think about e-commerce. They were starting to think about like online chats, online communication of various forms, and even actually digital currencies very early on. But the and there definitely was a stage where people were thinking about these things, and they were just kind of on the cusp of starting to get a lot of adoption. I think in the case of blockchains, it's we're in some ways at a similar stage, though in some ways it is a bit different, because like with the internet, like all of these applications, realistically, they did get at least some small core of users very early on, right? Like even things like internet-based bulletin boards, they had users all the way from 1990. Whereas, in blockchains, there definitely are things that people are using, and so people definitely are using Bitcoin. There definitely are applications on Ethereum that are starting to get some traction, but at the same time, it is a space that is still, like, I feel it's remaining theoretical for quite a bit longer than some other things have. I think like part of the reason why is because just saying, oh, you can communicate from A to B like that, and like anyone can talk to anyone. That's a pitch that is like I think very easy to make, and it's very immediate and clear to the user why that's a good and powerful thing. But with blockchains, like we're talking about openness, standardization, decentralization, and these tends to be more kind of abstract and idealistic values. And even if you can be convinced that having a economy and society that's built on top of these values is good for everyone in the long term, it's not something that necessarily makes sense for everyone now, right? Like it's not something that makes sense for like each individual to like really care about now. So like that's why I didn't just make the analogy to the internet. I also made the analogy to open source software, right? Because like if you look at something like Linux, like I used Linux for about 5 or 6 years, and I would always went on to like all the internet forums where they talked about it, and there definitely were lots of people that basically said, well, why do I care about these openness and freedom things? Like I'm happy with Microsoft Windows, I'm happy with Word, and they work very well now. Why should I even try to switch, right? And so like in some cases the direct consumer pitch actually did work, and there was a small core of users that it worked well for. But at the same time, like in order for the open source software to really take off, and in order for its kind of values to really manifest themselves in the way that's useful to everyone, it needs to take a kind of fairly complicated path. Although in the end, like as we've seen with Android, web standards, Chrome, it has proven very successful.
So can I ask, was that originally your initial appeal to Bitcoin. One thing a lot of people, some may know, some may not, but Vitalik was one of the original founders of the quite influential and successful Bitcoin magazine. And I'm just wondering, when you first discovered Bitcoin and you first came across it, was it the fact that it was open source that made you want to dive deeper? Was it the technology, or was it the implications as a currency? What was it that made you go deeper down the Bitcoin rabbit hole?
It's kind of the open source aspect, so though I think it's a bit broader than that. It was just the idea that you have this financial system that first of all is like completely open and accessible all the way down to the bottom levels, and where like I downloaded a Bitcoin client, I ran a Bitcoin client, you know, I earned a few Bitcoins, and then I like sent 11 and a half of those, or 8 and a half of those Bitcoins to buy a T-shirt, and I realized that, wait, you know, here we have like basically the main function of money in an economy, all implemented using a system that could run entirely just on like a few thousand computers that look like just like my own. Like it made finance really look like something that doesn't necessarily even require like all of these kind of faraway large institutions that like you need billions of dollars of capital to become, and actually made it feel like something that actually is kind of accessible and social and and something that like groups of people could basically just like put into reality on their own, and that's something that I found very empowering.
Okay, and you just mentioned that we're still, you know, very much in the early days of this technology and its life cycle. But there is very much a feeling that you know, within the next few years, within certainly the near future, we're going to start moving further away from the theoretical area of blockchains and more to the live production. There's a few barriers of adoption to getting there, to doing that. Some would say it's regulation. Others would say it's users. Others might say it's banks picking up and adopting the technology. Who do you think is going to be the main driving force between blockchain adoption in the next few years? Which group do you think would be leading that?
I think we're still at the stage where there's a combination of things that needs to move forward in parallel with each other. So one part of it is the technology itself, because even though the technology has been developing for about 8 years, there's still a lot of imperfections with it that I think still need to be resolved. So for example, if you look at scalability, right? Bitcoin can process about 4 transactions a second. Ethereum can maybe go up to 7 or 15. But like at the end of the day, if you want to do mainstream finance and not to mention mainstream like IoT or like high frequency derivatives trading or whatever else, like you can't do 4 or 15. You can't even do 50. You need 100,000.
Yeah.
Right? And so I think the blockchain scalability story really does need to develop like quite a lot, and part of that is going to require very fundamental low-level technical work. So that's part of it. And the other part obviously is the more kind of adoption side of the spectrum, and there I think it's a matter of first of all figuring out exactly what kinds of applications could be useful to people, but also it's about figuring out exactly what kind of path makes sense, right? So, like the thing with a lot of blockchain applications is, like for example, if you look at something like supply chain tracking, people say, oh well, if you took all of these companies and you made all of them use this common platform called a blockchain in order to keep track of every step in product manufacturing and shipping, then fraud prevention would become much easier. Like that's true, right? But that's not just a blockchain application. It's a coordination application, and coordination is across industries is hard. And the thing you have to answer is, first of all, like, is our blockchains actually that much easier at coordinating than whatever people were trying before?
Yeah.
And even if you do, like, you need to basically, like, what you can't do is, like, imagine if like the current mainstream financial system is on like one mountain, and the blockchain world is on a higher mountain, and you have and you have this like society of people that wants to go as high as possible, but they're fairly short-sighted and they're fairly risk-averse, and they don't want to climb down from the mountain, because if you climb down from the mountain, you get lower,
Yeah.
right? So you don't want to create a path that looks like you have to climb down a lot first, and only then once everyone gets down, you can climb up. You want to try and find a path where every step along the path looks like you have a positive slope, where every step along the path it by itself looks like a separate an improvement, at least to the people who are taking that step.
Yeah.
And you know, if you actually are dealing with a situation where you have these two mountains, that can be kind of hard. But maybe there are kind of, you know, the real world isn't just three-dimensional. Like it's very multi-dimensional, and maybe there are like paths that people can find where you can go from A to B to C to D, and every single step actually does make an improvement in efficiencies, at least for the people that take it. And I think finding those paths is one of the key jobs for an entrepreneur.
Yeah. So speaking of your own sort of entrepreneurial journey and the mad direction it's somewhat taken, if you had never discovered Bitcoin, if you had never developed Ethereum, what would you see yourself doing? And as a follow-on in the entrepreneurial guise, what sort of advice would you give to entrepreneurs here today in the room who may want to follow a similar fintech journey?
I mean, I would say to the first question, realistically, something in AI or machine learning. I mean, like that was the thing that I was interested in to some extent before like Bitcoin started taking over my life. And I mean, that said, though, I think like the thing with AI 4 or 5 years ago, and like even blockchains now, is that it's a field where there's already a lot of people who are doing things, and like for an entrepreneur, the way that you can be really successful is by finding something that there aren't that many people actually researching yet. Right?
Yeah.
Like finding something that's actually underhyped and underexplored, and pushing it forward to the point where it becomes hyped and explored, and you're the one at the center of it.
Yes.
And that's like, unfortunately, like that's not something where you can really give formulaic advice, and like often it feels like you're failing, and you have no idea how you're going to succeed until suddenly it comes to you.
Yeah.
You know? But like that, it's something that you might want to be watching out for, I suppose.
Yeah, of course. And to also probably share that sentiment about failing and failing fast. We have a few questions from the crowd here. We'll try and sort of work our way through them, and we'll start off with perhaps some of the more interesting ones. So these will sort of swing in different directions depending on what the crowd most wants to hear. But our most popular one that we have at the moment is, why would a bank use a private blockchain over something like a database?
So I think I'll start off by first of all going over one of the things that I wanted to talk about before my speech was so rudely interrupted by this wonderful session, which is what private blockchains actually are. And so to answer that, I'll probably also have to say what public blockchains actually are. So the way that these decentralized systems actually like come to consensus on kind of what the truth is, so like on what transaction came first on like whether or not coins have been spent, is they have like some kind of algorithm where you have many different participants in the network, and they all come to like it's kind of like a voting process. So like if some part of the network sees one transaction first, they say they might include that transaction into like a sort of package of transactions that they call a block, and that block contains one transaction. And then if the other part of the network sees the other transaction first, they make their own block containing that transaction. And now you have these two kind of competing versions of the truth that are in some way sort of dealing with each other. And you have the what's called a consensus algorithm, where basically like the part of the network that believes one thing keeps on building on top of that. The part of the network that believes the other thing keeps building on top of that. And eventually it becomes obvious kind of which part of the network is bigger, and everyone switches over to that version. So like I describe this in a very abstract way, because there's actually lots of different ways to implement this concept. So in the case of Bitcoin, you have this notion of proof of work where, because Bitcoin is a public network, it's a network where anyone can participate with their own computers. And the way that you create these blocks that sort of represent units of participation in the network in some way is by burning large amounts of computing power. So basically your computer solves these complicated math problems, and the math problems don't really have any meaning by themselves, except that by solving a math problem, you're effectively proving that you have enough computing power on your computer to solve that problem. And basically, the protocol measures the number of computers that believe each fact by looking at how many solutions to math problems there are, sort of backing that fact up, right? So if you have more computing power that believes A, then you can easily see that and verify it. If more computing power believes B, then you can see it and verify it.
Yeah.
And so you have this kind of duel of computing power in the network where some people are doing this process that's called mining, which is like trying to solve these computational puzzles on top of one transaction, and some people are trying to do it on top of the other transaction, and eventually one ends up kind of winning out, and everyone switches to it.
Yeah.
But that's so proof of work is this process where this is done through computational power. Now that's not the only way of doing it. So for example, there's a lot of researchers, including myself, that are looking at a technology called proof of stake, and they're interested in proof of stake because instead of relying on burning like large amounts of real-world electricity to run a blockchain, proof of stake essentially uses virtual assets to perform the same role, right? So if you think about any of these blockchains, like you have cryptocurrencies inside of them, right? You have Bitcoin and Ethereum, you have Ether, and instead of using work to prove that you own a computer, you can basically digitally sign messages with the same private key that owns some amount of digital assets, so like for some amount of Ether, and so you can prove that basically you're staking your Ether on top of some particular version of the truth. And so instead of having a duel of computational power, you have this kind of duel of digital assets inside of the system, but this theoretically has similar properties to proof of work in terms of being decentralized, in terms of like anyone can buy a computer and participate, anyone can buy Ether and participate, but it's much more environmentally friendly because you're not burning electricity, right? So like this is one way of doing it. So like these two approaches, they're both like what's called a public blockchain, and the reason why they're called public blockchains is because both of these approaches create a network where anyone can freely participate in the system. Now, both of these approaches have their limitations, right? And one of them is a limitation on security, or sorry, on scalability. Well, there's a limitation on security too, right? The limitation on security basically is that if you're a large attacker and you can spend more money than the rest of the network combined, then basically you can kind of outvote everyone else, and you can make your version of the truth always be the one that wins.
Yeah.
And like this is bad. If you can succeed at this, it means you can constantly attack the system. The other limitation is scalability, which is because these systems are really intended to be kind of very accessible to the common person, it's considered a desirable goal for it to be possible to run a node on this network using just like a regular computer.
Yeah.
Now, one of the properties of these systems so far is that in order to participate in these systems, you have to download every transaction yourself, verify every transaction yourself, keep track of the entire state yourself. Now, the challenge is that like if basically what those two things together mean is that all of the activity that's generated by the entire world needs to be processed on one single regular computer. And this creates a really like strict limitation on how much you can do on a public blockchain. Now, to deal with these two issues, people have come up with this alternative approach that they call private blockchains or consortium chains, right? So what this means basically is that instead of creating a network where anyone in the world can participate, you create a network where, let's say you have a network between the 30 banks and financial institutions within one country. Each of these institutions is given one vote, and the consensus process runs between these 30 groups. So there's two reasons why this is nice. The first one is you're not just relying on economics as a trust model, right? You're not just relying on this kind of duel of like who can throw like more financial capital behind an approach, like one transaction of two winning. You're actually relying on entities that are themselves trusted, and if those entities maliciously misbehave, instead of just being their money at stake, it's potentially their banking licenses at stake. And like that's a much harder, that's like a much stronger security model. The second thing is that because you're not talking about regular users running the network, you're talking about institutions running the network. You have this, you can actually scale it up much more. You can require every institution to have a fairly powerful server, and you can have this private blockchain process like thousands or tens of thousands of transactions a second. And like for some applications, I would say the amount of scalability and security that public chains have is fine. But for like a very high value, high throughput mainstream finance, at least right now, you might want a private or consortium chain. Yeah. So the question was, the question I answered was like, what's the difference between public and consortium? But like the question you asked was what's the difference between consortium chains and databases? So the point that a lot of people sometimes bring up when we talk about consortium chains is, well, okay, you have a chain that's between the banks. How is this better than a centralized system? How is this better than a database? Yeah. And the answer that I would give in reply is, first of all, I would say having 30 nodes in the network is still much better and much more decentralized than having one node in the network. Yeah. And so I think that's very important. And there are a lot of applications where you have like the banks or like the companies in some particular industry, and like they want to kind of standardize and work together in some way. And having a shared database, having like some notion of shared distributed state between them is actually the easiest way to do that. Yeah. And like doing that on a server is not going to work, right? Because like with servers, every bank has its own database, and you need to have these databases talk with each other. You need the databases to reconcile with each other. And what if there's mistakes? What if there's like some kind of like miscongruence for like one database has one thing and another database has another thing? Yeah. And like if you just use traditional databases, then you're going to have these problems. And
try keeping it on the chin.
Things and you're gonna have all these problems, and like this is part of the reason why in traditional finance, for example, you have to wait for like 1 to 3 days for transactions to settle. Yeah. Now, if you move all of this onto a consortium chain, then you have a shared database, and so you can have things like settlement finality happen instantly. So you do get a huge amount of benefit, right? Now that said, you definitely don't get all of the benefits of like openness, decentralization, standardization, interoperability that you get by using a public chain. But like, there's a trade-off, right? Yeah. Public chains have some advantages, and consortium chains have these other advantages. And depending on which application you use, like you should just like pragmatically look at the pros and cons and see which one makes sense. Yeah.
Cass, would you say the best thing for banks to do at the moment is collaborate rather than compete?
I would say to some extent is a fundamentally about operating, and like if every bank makes their own thing, then you really haven't gained anything. Yeah.
Okay, so well, sort of leads us on to the next question. What do you build in with blockchain technology that simply couldn't be done with the more conventional architecture?
And I would say that anything that you can build on a blockchain theoretically can be built using more conventional architecture, but the differences are in basically what properties it has. Yeah. Right. So, for example, there is a group in Taiwan that's using an Ethereum-based consortium chain, and the group is called AMI, by the way. The idea is that they're using a consortium chain to create an architecture for payments, where basically you have all banks that are participating in the network, and you have users that might have accounts at these banks, and then you have payment applications, and any payment application could theoretically connect to any bank account, and because the transactions all happen on this common ledger, you have this kind of really high amount of interoperability where even if one user has an account with one bank and is using one application, and another user has an account with another bank and they're using a completely different application, even still, the two can talk to each other just as seamlessly as they could if they were all using the same platform. Yeah. Right? And like that's something that is really powerful and efficient. Now that said, one other way that Taiwan could achieve this is by basically just like everyone agreeing to use the same application in the same bank, right? And like that's kind of the approach that China's taken, basically, like with everyone using WeChat and Alipay. Right? But like, that approach has a lot of cost to it, right? Because first of all, if you have a monopoly, then it's invariably the case that the monopolist is going to overcharge. They're going to abuse their position. They're going to like discriminate against consumers. They're going to try and leverage the monopoly to get monopolies in other areas, or like try and secure their position. So that's something that we've seen in the U.S. financial system, for example. It's also monopolies are also something in a situation where it's very hard for people to innovate. It's definitely not as kind of very accessible.
Yeah.
But at the same time though, a decentralized approach often has the weaknesses that it's not well coordinated, right? That you have all these different platforms and all these different systems, and all these platforms and systems really have trouble talking to each other, and at the interface, it's always very difficult. And I think the real benefit of a blockchain is that you can get the best of both worlds, right? You can have the coordination benefits almost as if you had a monopoly, but without the social and economic risks of actually having a monopoly.
Yeah.
And I think I would say that's one kind of way of making the pitch. Another thing is that if you're talking about any kind of international situation, that's a case where creating a monopolies is even harder and infeasible. I think we're right now especially after 2016, we're living in a world where people I mean, there's a lot of opportunity for international commerce and collaboration, but people don't trust each other, companies don't trust each other, governments don't trust each other, and having technologies that are decentralized and don't depend on any one particular group being nice is something that could, I think, really kind of benefit people and break through barriers.
Okay. And I understand, I think yesterday you were in Singapore, correct? And you managed to see some of the incentives that they have down there for entrepreneurs and the technology. In a lot of ways, Malaysia is still developing, and we're catching up quite quickly. One of the questions here is, what sort of advice would you give for beginners here in Malaysia to get into the technology? How do they start, or what more could potentially MDEC do to help spur on the technology here in Malaysia?
I think one of the important things that a successful blockchain community needs to have is a strong developer base. So people who understand the technology from a technical perspective, understand how to build things on top of it, and that's something that I think is there in Singapore to some extent, and it's in other places it's not there. So for example, I mean, in Hong Kong it's getting there, but it's in some ways that's more focused on just the financial side than it is on the technology.
Yeah.
In London, for example, I think there's both the technical base and the application base, and I think making sure that there are application developers that are technically skilled at doing things is important. Now how do you do this? I think it's a combination of different things. So one of them is collaboration with universities. One of them is just having developer workshops, developer meetups, any training events. In general, workshops that can kind of help people start to get up to speed on how to build things.
Yeah.
So that's one side of it. Another side of it is actually figuring out what kinds of applications people might be interested in. So I think one of the first steps is, I mean, first of all, identifying what the needs are, and even looking at the characteristics of Malaysia specifically, and seeing are there things that Malaysia could specialize in. So one thing, for example, that Singapore is not going to get into that much necessarily is mobile banking, because with Singapore, everyone has bank accounts. The banking infrastructure is already there.
Yeah.
But here, you have much more unbanked people. The infrastructure is much less well developed. And on the one hand, that's for the people living here today, that's a cost. But on the other hand, it's an opportunity to build new systems that are designed with the needs and capabilities of 2016 as in mind right from the start.
Yeah.
And you could just basically start from scratch without needing to look at any kind of legacy craft, and just build some things that are that meet people's needs very quickly.
Yeah.
So this could be microfinance, this could be digital identity, this could be micropayments, it could be some kind of peer-to-peer insurance. So I'd encourage people to try even get imaginative about what kinds of things people can build, and so basically instead of just trying to build X on the blockchain, try and think about what the needs are, and then try and think even almost from scratch what kinds of applications could meet those needs.
Yeah.
And in those cases where the mainstream infrastructure isn't there, decentralized approaches might actually be the ones that are more successful and that get through more quickly, because decentralized approaches, they just don't need that much existing infrastructure to start working. You can just deploy the software, and people can just start running it all on their own.
Kirsten, do you see perhaps some of the greater use cases for the technology happening here in Asia as compared to America and Europe and other places?
So I think Asia has several things going for it that might make blockchains interesting. One of them, I think, is just a lack of existing infrastructure, or just a relative lack of, everyone having a bank account that that already has everything that they want in it and that they're already used to.
Yeah.
And this could involve just like money internal money transfers. It could involve remittances. I mean, there are lots of things that this could entail. Another one is that unlike the US and the EU, I think in Southeast Asia you're going to have much less kind of international coordination on a government level.
Yeah.
Because on the one hand, you don't have these you don't have a large government controlling everything like the US. You don't have the EU that can impose common financial standards. And to some degree, yes, I follow geopolitics, and people here are kind of at each other's throats a bit more than in other places. And technologies that resolve trust issues, could actually be quite valuable if you're looking at a kind of regional perspective.
Yeah.
So it's some of all of those things together, I think, mean that there is an opportunity. This is especially if you look at kind of Southeast Asia more generally, including Indonesia, Philippines, Vietnam, Cambodia, just the whole region. And there's the need for finance. There's the need for international trade.
Yeah.
There's the need for remittances. There's the need for alternatives to traditional financial solutions. So I think there's a lot of potential there.
Yeah.
I'd also in general, right? Even one of the other things is that because there's, I've noticed this particularly in China, but I think it's to a large extent the case in Asia generally. There is a culture around being well adapted to smartphones, being well adapted to using new technologies.
Yeah.
And that's something that could really be leveraged in order to make build systems that are much more efficient and that properly take advantage of the capabilities that people have to offer right now.
Yeah.
Right. And so, if you can start with the mindset that you don't even necessarily need bank branches. All you need is phone applications. And if you just start with that kind of mindset, then you can build things that are very low infrastructure and that can get a lot done fairly quickly.
Yeah. Okay, so going on to our next most popular question. Banks rely on money replication and multiplier effects for profit. If blockchain's purpose is to fault this, would banks still adopt it?
So I would say, first of all, it may well be the case that blockchain technology will reduce banks' profit as a category. But even still, I think for any individual bank, it makes sense for them to be the first one to get in, and to make sure they don't get left behind.
Yeah.
So I think that competitive component is always going to be, I think, in people's minds. At the same time, also I think it's not at all clear that banks are going to just either decline or disappear as a category. I think it's definitely the case that the activities banks currently have are going to become less and less profitable. But there's nothing preventing banks from discovering new industries or new services that they can provide, and so that instead of their role disappearing, their role ends up kind of changing or evolving in some way.
Yeah.
And that's, I think, something that they really should be looking at. And blockchains can be part of the story. A third, one example is they might potentially even help banks at making themselves more international, for example.
Yeah. Okay. And how do you see in the future various blockchain systems eventually communicating with each other?
So one of the nice things with blockchains is that they're an environment where every single transaction, every single block, every single message is cryptographically signed, and so it's actually very easy to interoperate between different blockchains, basically because all you need is for one blockchain to be able to verify the messages that are created by another blockchain. So there are examples of this already. So for example, there's a project called BTC Relay, which is a piece of code that lives inside the Ethereum blockchain. And that piece of code can automatically verify anything that happens on the Bitcoin blockchain. So like you can have Ethereum applications that automatically directly like do things that are like based on whether or not some event in the Bitcoin blockchain took place. So like that's just an experiment, right? And like it has some use cases. Like you can make Ethereum applications that accept Bitcoin, but it's a model that you could potentially use, for example, to interoperate between like the Ethereum public chain and Ethereum-based private chains, to interoperate between Ethereum and other blockchains, to interoperate between different private chains. So in general, I think as long as these systems add in like just that minimum level of cryptography that's needed to make their systems kind of accessible and verifiable. Like communication is something that almost just it's almost harder to prevent than it is to allow. I would say.
Okay, and one of the questions here again is that Ethereum is billed as the next big thing after Bitcoin, although they do note that they're both very different and serve different purposes. For anyone who's perhaps new to the room or maybe just recently stumbled across Ethereum, what would you say is the big blue sky vision for Ethereum? What's the end goal for what you've developed?
I mean, so as I was saying before, the starting vision is to create a blockchain that is general purpose. So instead of being limited to like some specific set of applications, you create a blockchain that has this built-in programming language, and so any application can be written on top of it. Whatever application you have, you write the rules and like the business logic of that application as a piece of code, upload the code to the blockchain, and the code can just run.
Yeah.
And these applications can also very easily interoperate and talk to each other. These applications can use each other in various ways. So for example, you could have one application on a blockchain that is a currency. You could have another application that is an identity system. And you could have a third application that is a financial contract that uses the currency and that uses the identity system in some way. So like the more applications you have on Ethereum, I think it's also a platform that's very friendly to this kind of synergy.
Yeah.
Where like all these applications, the more of them you get, the more they complement each other, and the easier it is to build more and more powerful new stuff. And like that's something that I think is starting to happen already. Right? So those are the kind of basic technological values I guess that Ethereum has. Obviously, beyond things like openness and authentication and like resolving trust that are common to blockchains in general. In the long term, we're also really care about things like privacy, security, scalability. So like all of these challenges that still stand in the way of making many kinds of blockchain applications. What we basically want to do is we want to keep on working at and resolving those problems in parallel with those applications getting developed, so that like they can build version 1 on Ethereum as it is today, and then when they have to build version 2 that has millions of customers, where they actually care much more about privacy and more stringent regulatory requirements or whatever, then Ethereum can be more powerful and like grow in time to meet those needs.
Blockchain blind spots. What are they all about, and why should anyone in this room be interested? So, some areas that are, I think, a bit underexplored. First of all, the intersection between blockchains and kind of social media or Web 2.0 applications. So, in general, right, there's been lots of large institutions that have said nice things about blockchains that are doing like internal experiments and proof of concepts. You have banks, you have energy companies, you have IoT companies, phone manufacturers, governments. One group that's like very conspicuously absent is like Silicon Valley software companies. So Google almost nothing. Twitter almost nothing. Facebook almost nothing. Uber, Airbnb almost nothing. Now so I think like there's an area there that is a bit underexplored, and I think blockchain applications that use like all different aspects of blockchains, I would say, including cryptocurrency, including financial contracts, including identity, including reputation. I think there is some like an underexplored territory in using those components to build better social media platforms. Yeah. Now, and I think also like those kinds of platforms are areas where like having there are problems that potentially could be solved. So, we talk about blockchains as being democratizing access to truth.
well, guess what? You know, there's been all these scandals in the last month about like fake news on Facebook. So there's been like people talking about, you know, like how social media platforms can create bubbles of information where people like don't see like anything that contradicts one particular viewpoint. You know, there's concerns about like restaurant reviews being fake. And so, look, there are all of these real issues in the kind of social media space. Even another one is like something like even like faking upvotes on Reddit. So like all these different issues that I think crypto, like blockchains, so, you know, smart contracts, cryptocurrency, whatever based solutions really could help alleviate. And I think there still aren't enough people looking at that. So that's one area. As far as finance goes, I think there's like roughly the right amount of attention going into it.
Yeah.
As far as identity goes, I think there's a good amount of attention going into it. In terms of finance, I think another thing to look into is, as I've stressed before, don't just try and like take things that already exist and put them on a blockchain. Even like look at more decentralized approaches of doing things. So for example, don't think of insurance as something where you pay X dollars to purchase a policy from a company. Think of insurance as 10 people putting their money into a collective pool run by a smart contract, where then after that money if any of them have some kind of event that needs to be paid out, money gets taken from the pool and paid out to them, right? So like that kind of mutual insurance model, that's something that, I mean, first of all, it's like a really low infrastructure and really easy to deploy, and I think it actually could solve a lot of the problems with the current insurance industry, because like if you have a mutual model, then like every actor in the system is getting the exact same terms, and so you know you're not getting screwed or overcharged, right? So that's like one thing. There's also a group in Silicon Valley that I talked to a month ago that's doing rotating savings and credit associations. So like a more kind of decentralized approach for saving and lending. You can think about various kinds of micro investment, and you can even think about crowdfunding. So like, can you do some kind of like micro crowd fund to invest in a restaurant or to invest in building a hotel? So something on the scale of like $1 to $100,000. So try and think about things kind of more imaginatively, and then like simultaneously, like imaginatively and pragmatically and realistically. And I think there are like potentially very interesting things that people can build.
Okay, so elevator pitches. I dare say you're familiar with them. If you had to give a 30-second elevator pitch on blockchain, which I'm sure you do quite frequently, what would you entail? What is the quick pitch for blockchain to get people hooked?
I think to some extent it depends on your audience. So one thing that I sometimes emphasize is what I talked about this morning, which is like the value of openness and permissionless systems where anyone can participate, and how in order for like that spirit to make it into the 21st century, you have to look beyond just open source and start thinking about open execution and like decentralized networks. If you're talking about mainstream like financial institutions, then you know, I want to emphasize interoperability and the fact that you can have coordination without monopolies. A third, and I would also emphasize interoperability in general. Emphasize the idea that you can have platforms where every single operation that anyone ever makes is cryptographically recorded and put into an authenticated ledger forever, and so that makes things very easy for people to authenticate and track. Also, I would emphasize the aspect of building systems where basically even the extent to which the application developer themselves can cheat the customer is very limited, right? Because that's something where, if you look at the spirit of open data, for example, right? Look, there's been a movement in the last 5 years to try and create systems where if a user has data inside of a platform, to build systems where if that user wants to export that data, they can, right? So you don't have lock-in. And with blockchains, that's also something where like you can take that spirit and you can really make it like 5 or 10 times stronger. So to give one example, if you look, there's a company out of Singapore called Autonomous. And like what they're basically doing is they're doing like corporate governance. So like transferring company shares, voting on resolutions, hiring and firing directors, all on the blockchain. And one of the nice things about doing things on a blockchain is that if you at any point decide you don't like Autonomous, or if Autonomous shuts down, you can just export your private keys, And theoretically, you could do everything that you were doing before just with the command line by sending transactions directly to the Ethereum blockchain, right? And like that kind of property is something that's really powerful, right? So that's also something that I think is worth emphasizing. If we're talking about blockchains for payments and cryptocurrency, then I would just emphasize, money that works like email. You can send, any amount of money from Kyrgyzstan to Guatemala, and the transaction's confirmed as quickly as an email. Like that's something that traditional finance still just like can't give you, right? And even like for the Ethereum Foundation itself, we often pay our contractors in Ether because just figuring out the traditional like international banking wires is just too difficult, right? So I think like depending on what you're talking, who you're talking to, and about what you're talking to, there are all these different kind of pitches and that can be kind of compelling in different ways.
Yeah. Okay, great. And to sort of move on from that to evolve from that, one of the terms that everybody associates with Ethereum is smart contracts. Could you maybe just give a sort of low-level introduction to what is a smart contract? How is it formed? And why this is the thing that banks and a lot of other organizations and individuals are now starting to implement.
Sure. So the basic idea of a smart contract is that it's a computer program that directly controls digital assets, right? So right now, in general, when you think about kind of having control over assets, it's generally as you can have digital assets directly under the control of a piece of code, where that code can specify arbitrary conditions. They could even be stateful conditions on how those digital assets can be moved. And now, what exactly that can be used for, like it depends. Even if you look at something like a financial derivative, right? Person A puts in $50, person B puts in $50. After 1 week, person A can get out 50 plus X, person B gets 50 minus X, where the value of X is dependent on some complex set of rules that might have to do with like some stock or currency prices. So look, that's an example of something that could be done with a smart contract. If you look at insurance, party A puts in let's say 10 people put in X, and one party might be able to take out 10 times X, but which party that is depends on some complex set of governance rules. So like the ability to have assets that are controlled directly by kind of rules and not by people, right? You can even think about it as sort of digital rule of law in some way. Like that's what it literally is. It's like digital property that's directly controlled by rules and not without even needing people to kind of intermediate the rules. Yeah. That's that's the kind of idea that smart contracts are getting at.
It goes to the principle that the internet code is law.
Yeah.
And one of the questions that we have here, which is is extremely valid for those who are just being introduced to smart contracts and the technology, is that when code is law and there's maybe an issue with the code, one of the questions here, it's just phrased, how can a smart contract work in an immutable and irreversible environment when systematic risks and possible bugs are prevalent? So what's your take on that?
Right. I mean, there is a few approaches. I mean, one of them, as we've seen, is obviously to break the law. So to basically do a kind of hard fork of the chain to fix whatever got broken. But the problem with that approach is that it is extremely expensive to kind of pull off correctly. Yeah. And like even though that can work for kind of one-time things where there's like 15% of the value of the entire blockchain at stake. Yes. Like if we're talking about like a mainstream environment where you have all these applications that are on a blockchain and you have all these like different users that would have to install the software, like that's not something that's going to be realistic long term at all. Yeah. So if the kind of approaches that would work much better are approaches where you have some degree of security that built in through mechanisms that are inside of the blockchain. And this can take several forms. So one of them is that people are looking at this approach that they call formal verification, where basically you can have computer programs automatically verify certain properties about smart contracts. So for example, you can automatically verify that everyone can get their money out of a smart contract. Or you can verify that without certain things taking place, someone can't get money out of a contract. If you have a smart contract that implements an exchange, for example, you can verify that if you put $100 in with an order that says that you want to buy 2 grams of gold, either you get your $100 back or you get your 2 grams of gold.
Yeah.
Right? So you can make mathematical claims like that, and you can automatically verify them. Now obviously this doesn't solve everything, because maybe there's a claim that you forgot to kind of care about, or maybe there's you have a bug in the code, and you have a bug, and the way that you wrote one of your claims is actually incorrect, and so the formal verifier just kind of misses the issue completely. So it doesn't solve everything by itself. Another kind of strategy has to do with escape hatches. So the idea with escape hatches is pieces of code that can detect when something goes wrong, and when that happens, turn control over to some party, right?
Okay.
So that party could be one person, it could be a group of people.
Yeah.
It potentially, like in the case of the public Ethereum chain, it could even be like a vote between everyone who holds Ether.
Yeah.
So that's another approach that you could take. The third thing that you could do is you could try to write the code in a kind of much more redundant way. So you could even try and write the code in such a way that for anyone to take large amounts of money, like multiple things have to fail at the same time.
Yeah.
You could design your code in order to have like large kind of time delays. So for example, in the case of the DAO, one of the things that even made the hard fork possible is the fact that the thief had to wait 35 days in order to move the money out.
Yeah.
Right. And if the DAO did not have these like time delays, then any kind of fork would have just been impossible.
Yeah.
So that's also one kind of issue that is fairly important to one approach that's very important to look at. I think realistically, no application is ever going to be perfectly secure, but I think using a combination of these strategies, you can definitely get closer and closer.
Yeah, and I think as the experience develops and as the network grows, you start to implement best practices, and they start to get shared between the community, and it picks up.
I think like the other important thing also is that there are developer tools, and like there are protocol changes that you can make in order to make it harder to do things that are stupid.
Yeah.
So like one example is that in the Ethereum protocol, like in one of our recent hard forks, we added a change that basically it removes a feature of the protocol that's called the call stack depth limit. So what that basically means is that if a contract talks to another contract, and that contract talks to a third contract talks to a fourth contract, and so forth, like in the original Ethereum protocol, there was a limit to how many times contracts could talk to each other. And so there are attacks against systems where you could basically like have an attacker kind of talk to themselves like let's say 1,000 times, and then talk to a contract, and the contract expects that it can talk to something else, but because it hits the limit, it can't. Right? Like this was one way to attack a lot of systems built on top of Ethereum. So we made a change to the protocol where we basically kind of got rid of the limit, and instead of the limit, we came up with another approach of dealing with the issue that the limit was meant to address. And because of that, like that kind of attack doesn't exist anymore. Right? So I think the moral that we learned from the story is that you really don't want to have features of the protocol or features of the programming language that are unintuitive. Like you want to have a system where basically what you see is what you get. If a program looks like it does something to like a fairly inexperienced developer, that's the thing that it should do. Right? There shouldn't be any kind of weird surprises. Yeah. And continuing to improve the protocol and the development environment in such a way as to meet those goals is, I think, something that's very important.
Yeah. I mean, there's definitely been some difficult, somewhat decisions that you've had to make as of late, and basically more and more people are now starting to put money into Ethereum, are starting to trust Ethereum, are starting to develop with Ethereum. How quickly you have sort of responded to some of the issues that have happened recently has been somewhat a great example to other blockchains such as Bitcoin, who are still arguing about much smaller things. But how much longer can you be at the helm? Do you want to really be at the helm, or do you have plans to much more further democratize this and be able to take these sort of situations out of your hands slightly?
I think to some extent it's going to democratize itself over time, regardless of what we at the Ethereum Foundation end up doing. So I'll give one example. So in which Ethereum is actually, like, the development is getting fairly decentralized already,
Yeah.
which is that one of the things that's unique about Ethereum is that there isn't just one implementation of the Ethereum protocol. Like, there's about 5 of them, and like there's about 3 that are in regular use. And 2 of those are not even written by the Ethereum Foundation. They're written by independent companies. And so when we make these hard forks, when we change the protocol, we actually have to get agreement between all these different companies and you know the foundation in order to actually push changes forward. And to some degree, that actually does slow us down. But at the same time, it does mean that we can't just push changes through without getting broad agreement about them, right? And I think as the ecosystem continues to mature and as there are more kinds of users that are using Ethereum, I would expect that like basically the number of parties that we would need to kind of coordinate between to make any kind of changes is going to increase, and over time it is something that's going to become kind of harder and require a broader consensus. And like that's something that's just naturally going to happen over time. And like ultimately, you know, at the end of the day, like we don't want to be the kind of centralized controllers of the platform. And like to some extent, we have that role because we're the developers of one of the clients that very many people use, and that, you know, we've gained a lot of trust as kind of people that understand the technical issues behind making changes. But as the community grows, the number of people with that kind of expertise is only going to increase. And I'm kind of hoping that the community does democratize more and more on its own. Now, of course, one of the questions is, you know, can it find a way to democratize without at the same time being just like unable to make any changes whatsoever? Because that's a failure mode that we're also really keen on avoiding. I mean, we're hoping that we can. I think one of the important things that we're doing is that even though we have all these different implementations in order that makes changes harder, we also have a culture where like all culture expects constant improvement and expects new versions to come in fairly regularly, and so that's something that people expect. And I think that's both important.
And someone's asked in the crowd here today with all this extra influence and potential stress, does it keep you up at night? How well are you sleeping at the moment?
Sometimes it depends. I mean, when that last accidental hard fork happened, I did only end up sleeping for 2 hours. So you know, it's I mean, it definitely like it's definitely the case that sometimes random things happen at random times, and we just have to be awake for it. And but at the same time, I also feel fairly confident that because we have this like fairly large and growing team, and we have a lot of people that kind of understand what the challenges are and can call attention to any issues that come up. I think it's getting easier and easier for us to deal with things. Yeah.
Okay, and just to sort of take it to the higher levels for a moment. In terms of regulation, there's a lot of different things happening in different countries. Some are taking a very pro-Bitcoin blockchain approach, others quite anti. For you, what do you feel regulators should be doing in the space at the moment? And are there any examples of countries or certain bits of legislation that you think should be adopted further afield?
Right. So I think one part of the answer is just like not doing bad things. So this is like not just like banning Bitcoin or like blockchain technologies completely, and even and if I can't convince them not to ban Bitcoin, at least understands that there's a big difference between things like Bitcoin and, let's say, non-financial applications.
Yeah.
But you know, ideally, I think all categories of blockchain applications have their value and should be respected. Also, like things to avoid would also be adopting things like the bit license. So where you have these New York regulators that thought that they were being kind of very progressive in implementing like comprehensive legislation that would kind of clarify things. But in reality, what that's often led to is you have these companies that say, oh, like all this process of like $5,000 application fees, hundreds of thousands of dollars of lawyer fees, like putting in everyone's fingerprints and so forth is way too hard, and we're just going to say our services are available everywhere except for, you know, North Korea, Iran, and the state of New York. And like that's, you know, you don't want Malaysia to be, you don't want Malaysia to be number 4 on that list. And I'm optimistic and I don't think that it will be. So part of like not imposing kind of these overly burdensome restrictions is one important part of it, but it's also like, I think it's not the only part. I think there is also kind of things that governments can actively do in order to kind of help move the blockchain industries in their countries in a positive direction. I think one thing that regulators should do before taking any action is just talk to the people that are building things in their country and see what concerns they have. So one example is that there are many places that are starting to create blockchain or fintech sandboxes.
Yeah.
And the idea is that this is meant as this really nice progressive kind of pro-innovation measure that says, you know, oh, you know, we're not going to kind of impose our full regulations on these startups, and we can kind of help them grow and get off to a safe start. And these sandboxes do a good job of protecting you from the government, but the problem is that they don't protect you from an even bigger problem that a lot of these companies have, which is that they can't get bank accounts, right? So, like, that's a big problem that a lot of companies have, and that's a problem that I think regulators could really do more in trying helping to solve. So, like, helping to just make sure that or try as much as possible to make banks feel comfortable about banking these like blockchain startups.
Yeah.
I mean, sometimes. In themselves, like participating in various kinds of blockchain applications, participating in consortia, building blockchain-based payment solutions, looking at blockchain-based digital identity. So I think, in general, banks already are, and I would say should continue like having actively people looking into the technology and seeing what they can build on top of it themselves.
Okay. And we haven't got a great deal of time left, so I'm just going to try and move on to some of the more higher level questions that we have. I think there's quite a bit of mixed experience in the room. I think there's some people who are probably already quite familiar with Ethereum, and those less so. But for those that are maybe a little bit more familiar with the network and what it is, scalability is a pain point for Ethereum. How is Ethereum solving this complicated sharding problem? And wouldn't it potentially introduce more problems to a potentially fragile state?
So, first of all, I'll explain what sharding is. So the basic idea here is that instead of having a blockchain where literally every single user has to keep track and verify every single transaction, you would split up the state and you would split up the transactions into many groups. And so every node in the network would only be verifying and participating in the consensus for a small portion of transactions. Now, the reason why this is nice is because now you could have a system which can still run only on like basically just a large number of regular people running regular computers, but can process many more transactions than any single computer can handle. And if you do sharding correctly, you can still have the system be like almost exactly as secure as it was before, and like you still have security, because even though it's not the case that every user is verifying everything, like it's still very important to keep the property that if any user wants to verify any specific transaction, they still can, right? And like that's one very important property that our sharding schemes are all designed to have. So like theoretically, if some malicious miners try to, or proof of stake validators or whatever, trying to like get some blocks in that contain invalid transactions, even though some users might not see those transactions by default, like if some people will see them and they'll be able to kind of spread around cryptographic proofs that show the evidence that very clearly shows that look, these people are trying to do something malicious, and you should ignore them. So like creating a system that has all of those properties is something that I think is definitely possible, and that we're actively in the process of doing this. But at the same time, this is something that has quite a few technical challenges, and it's still things that needs to be kind of figured out, especially in the details, in order for this to work really well.
Yeah, it's not an overnight problem to solve, but in terms of overnight traction, what would you say are some of the applications that you feel are getting some of the biggest traction, some of the most attention on Ethereum, and which are some of the applications that you are personally more excited about being built on Ethereum right now?
I think just to go through the list, finance, I mean, deserves a lot of hype and is already getting a lot of hype.
Yeah.
Identity deserves a lot of hype and is already getting a lot of hype. Things like non-financial applications, supply chain tracking, I think getting a lot of hype probably, although it's a bit earlier stage.
Yeah.
Virtual assets, so assets inside of games, for example, even assets that are kind of non-financial, is an area that could be explored a bit more. Also looking at registries for property other than money. So company shares, like birth and death records. There's ownership of land property. Like that's, I would say land registries are kind of correctly hyped at this point, but some of those other like more kind of more obscure ones are a bit underhyped.
Yeah.
In the financial contracts, financial derivatives, I think there's already enough people doing that for the moment.
Yeah.
Putting digital assets on a blockchain, I think is something that like it feels boring, but people need to do it because all the other applications depend on it.
Yeah.
So like it's one of those things that's like not too glamorous by itself, but it's really, but it's really important just because of like what could be done on top of it.
Yeah.
Then there's also things around insurance. I think. Especially things like what I was talking about in peer-to-peer microinsurance, peer-to-peer microfinance, like that stuff could use a bit more interest, and like that's an area where people here might look and be interested in looking into a bit more. Then energy trading, maybe worth looking into. I would say this like blockchain in social media thing is worth looking into.
Yeah.
On the identity side, I think. One of the people are looking into kind of bank KYC style identity, but I think it's also important to note that identity is something that really could be a building block in a much larger way. Like identities are something that like we use to like log into online internet forums that we use to interact with financial services, that we use to interact with the government, that we use to talk to each other through chat applications.
Yeah.
And I think there's an opportunity for a much broader concept of identity. And like if people build these things, and particularly if people build them in a way that's relatively standardized, then the next thing that you can do is build applications on top of it. So like another piece of advice that I think is important to give to blockchain startups is basically be willing to standardize, right?
Yeah.
Because one of the things with startups is that I feel like a lot of them don't like standardizing because either they want to be unique or they're
want
told
to be the one to
yeah they want to be the one and they've been told that like the way that you're supposed to win is by dominating the market and being a monopoly. But like blockchains aren't about that, right? Blockchains are about standardization and collaboration. And if people don't standardize and they don't collaborate, then you've gotten nowhere.
Yeah.
So, like, I feel like a large part of the benefit of blockchain is that you actually can go from having these large monolithic services that combine lots of different things into this more modular ecosystem where you have an identity layer with lots of identity providers, reputation layer with lots of reputation systems, a financial layer with lots of digital assets, and applications that kind of sort of pick and choose and like can talk with anything on any other layer. And I think like that, like building what you're building with that kind of ecosystem in mind is something that's important.
Okay. Last question? Okay. Okay, well there's, just two we'll do very quickly. Someone's asked, Asian-wide blockchain trade financing platform, possible, question mark. I'm just gonna say yes to whoever's put that in. So for the very last question then, sort of like your parting words for Malaysia, this being your first time here. There's quite a number of people in the room who potentially hold the power to be able to take this technology forward and to be able to see it progress. What is the best advice you can give to everybody in the room with regards to the next 12 months or so of blockchain development and what they should be looking at and where Malaysia should go from here?
I think to some extent it depends on who you are. So for example, like if you're a developer, then I mean both like participating in and helping to build the development community is something that's important, and that's going to be important regardless of what application you're going to build.
Yeah.
If you're talking about if you're an entrepreneur, then I mean both like trying to look for applications, trying to figure out what it is that makes sense to build, figuring out what could realistically get adopted. I would also say expand your horizons. So I think a lot of the more successful applications could actually be applications that don't just look at Malaysia, but that actually try and look at kind of Southeast Asia as a group and get deployed like everywhere at the same time. I would say if you're working for a bank, then study the space, look at what other banks have done.
Yep.
I would say, I mean, before sort of starting any or even participating in kind of very expensive consortiums yourself, also consider seeing if you can like just like looking at what people have already done and published already, and like seeing if there's things that you can start kind of just like figuring out a bit by yourself to get and getting a hands on things yourself, and then kind of over time figuring out where it makes sense to collaborate. If you're a regulator, then I would say just talk to people, understand what people's concerns are. Understand what people are trying to build. Understand kind of what people's challenges are. And I think in general, like if everyone can be collaborative, I think you can really make the Malaysian blockchain industry a success.
Okay, so I guess it's collaboration, emulation, and innovation in the top three. Ladies and gentlemen, Vitalik Buterin.
Thank you very much. Thank you, Johnny. Thank you, Vitalik. I know there was some complaints a little bit about the sound. We're fixing that, and then the good news is that we're doing the live broadcast of the session with Vitalik. So everyone will receive a link on YouTube, so we'll be able to watch it again and carefully, in your sofa at home, and don't miss anything important. And another good news is that lunch is coming, and Vitalik is staying for a little bit to network with you guys. So please feel free to come and ask him questions. That I know we received a lot of questions, over 50. We were not able to answer all of them, but we will make sure to address some of these questions to other speakers, which are exciting people coming next after the lunch. And the last thing, so I'm holding this interesting thing in my hand, is that this is black box, which is a very cool gadget. And each of you will get this one, okay? It's VR glasses, okay? So all you need is to place anything, share on the social media, put a hashtag FinnoVasia, come to our staff in the back in the registration desk and get your VR glasses. Thank you again. Thank you, Vitalik. Thank you, Johnny. And see you all after lunch.